And basically, to run this the robot, we use this very basic logic. Is always going to look for the black line first, and then when it sees the LEDs, it will turn right, go left, or if it doesn't see anything, it's going to keep on going straight. The test that we did, basically, we tested with different LEDs, colors. And at the beginning, we wanted to use actual colors, like have a sensor that would like interpret the color, but that was too difficult. And we found that the green LEDs don't work. For some reason, the light sensors don't read it. So we changed that up. We stuck to yellow and red. Basically, and also at the beginning, we had the intersections white, and it wouldn't read it. So we had to make it solid so it can actually go through the middle and actually read the sensor, because it would get stuck and it wouldn't go all the way through and read. And the future improvements, you'll see later on in our thing, the robot is not as stable as we would want it to be. I think it will be more accurate if it would it will have a smoother, it will roll smoother. So maybe like other sensors, ultrasonic sensors would work better, and maybe having some kind of walls to kind of instruct it a little bit better. And actually instead of having LEDs, have touch sensors instead of LEDs, so it would close the circuit, and we wouldn't depend on the actual light sensor responding to it. And basically, the lessons learned, we learned that photoresistors are very sensitive. You have to be very careful. Sometimes the light affects it, and you think you have a good project, and then it doesn't work. And we also got our hands dirty, had a lot of hands-on experience with machining and stuff like that. And basically, we have some videos here we want to show you guys. This video, it's the first video we're going to show.
It's not playing. There it is. Click it again.
This is the first iteration. It doesn't work, and like I said before, the intersections weren't solid, so it got stuck there. It didn't want to go through to read the intersections and the LEDs.
There, I mean, it's looking for the black, but there's no more black to go to. That's why it doesn't know what to do.
The robot got confused before it could read the LEDs to direction it, and that's what was happening there.
In this video, the second video, we fixed it, but there's still some error in it.
It's going to go straight.
You're going to see in this video that it skips over an LED. Alignment is really critical for this project. We adjusted the photoresistors to read right over the LEDs. If it wasn't over the LEDs, it wouldn't turn properly. It wouldn't read the signal, so continue going straight and things like that. So alignment is really critical. To do that, we had to adjust the IR sensors to read the line directly and make sure that the line is centered with LEDs. You're going to see here,
right here.
At this point, it should have
turned. The red one is on, it should turn right, left, but it kept going.
Continue going straight because the alignment.
But we put it back, and it again, because of the alignment, we put it back, realigned it, centered it, and it turns. So it works.
Another thing we figured out is the way it follows the line, it reads a signal. It could differentiate whether black or white, so it reads the signal, and when it sees the black, it could read the edge of the line. That's how it follows it. But it read too fast, so it will continue going before it read the sensors. So we added a lot of pauses, so it slows down the program, and it could read the LEDs before it actually sends signals to follow the line. So this is a presentation of how it's going to work properly.
And basically, in conclusion, the robot does work. It has some flaws. I would say we're about 95% accurate all the time. It just depends how shaky it gets right before the interception, and like sometimes it does skip, like as you saw, but it should work pretty much. And we really used I think what we learned in this class, engineering and programming, to get this thing to work. And we also like to thank the professor and VayneRx, which is
Routine.
James works.
That's where I work. That's where we use to fabricate the bumpers and make everything work efficiently.